Greetings everyone and welcome to another screencast from Dev Bootstrap. In this video we're going to cover the Uniswap protocol and look at some of the exchanges, how we can create exchanges using factories, how we can interact with these smart contracts to basically perform swaps from Ethereum to tokens, from tokens to Ethereum, and from tokens to tokens. And we're going to just basically cover some of the concepts, some of the logic, and take a sneak peek at the white paper. So first of all, what is Uniswap? Well, Uniswap's website over here on uniswap.org describes itself as an automated liquidity protocol. And further down here, it says that it's a fully decentralized protocol for automated liquidity provision on Ethereum. Well, this basically means that anyone can create their own exchange, add liquidity to that exchange, and then anyone else can start trading those coins on the Ethereum network. Now, this will all become a bit clearer when we look at an example. So let's have a look at the interface to start with. So this is the Uniswap interface, the user interface for Uniswap. And we can see here that we can trade from a coin. The default is Ethereum, so let's put in one here. And we can trade it for, let's say, DAI coin, D-A-I. And we can see that we can get a price of 226.291 DAI for one Ethereum. Okay, that's the exchange. And this is essentially coming from a smart contract. It's coming from the Uniswap smart contract. And it's a liquidity pool, essentially. And we can actually add liquidity as well. And we can also create our own exchanges. So let's take a look at how this works. So I've drawn up a few presentation slides here to run through this. I'm only going to cover the high level. I'm not going to go too deep into the mathematics, into the equations of how this all works, but I'm going to just cover the basics, and we may go deeper in future screencasts. But what I'm going to cover today is how we can create markets using the Uniswap exchange factories, how we can add liquidity to markets via the Uniswap exchanges, and then how we can swap Ether for tokens, how we can swap tokens for Ether, and how we can swap tokens for tokens. Okay, without further ado, let's go over to the first example, which is the Uniswap factory and exchange. So over here, I've got my little market maker dude here, and he's going to create a market for us. And he's going to create this market on Uniswap. And the first thing that we have to do is use the Uniswap factory. And so what I've got here is a diagram that shows the Uniswap factory smart contract. And by the way, in these diagrams that I've drawn, I've taken them from the white paper, and I've also taken them from the actual source code of the smart contract. So that's why you see perhaps these maybe funny looking names, but these are actually the names used in the smart contracts. So if you are a smart contract developer, this is a nice way to perhaps get a high level overview of the Uniswap protocol using the smart contract namings. So anyway, so we're here in the Uniswap factory smart contract, and the market maker needs to create an exchange. So they call the create exchange function, and they pass in the address of the token that they want to register the exchange for. Over here, it calls this function, which is essentially like an instantiation function, like you might have in object-oriented programming. It essentially takes the exchange template and creates a new actual Uniswap exchange at an exchange address, so an address on the Ethereum blockchain. And it calls a setup method with the token address, which essentially creates two empty pools, an Ethereum pool and a token pool. So these pools are both empty at the initialization of this exchange. Meanwhile, back over on the Uniswap factory, the exchange address is registered, and it's registered in a token to exchange mapping, where the token address is mapped to the exchange address. So this allows us going forward to get hold of the exchange by just simply passing in the token address. We can also get the exchange via the exchange address, and it will return the token address. So there is actually a reverse registration of this, and an exchange to token address registration. But I just put in that one for this example. So at this point, we've got our new exchange, but it's empty. So what we need to do is add liquidity. So let's head over to the next slide where we're adding liquidity. So over here, I've got my little liquidity guy who is providing liquidity to this exchange. Now, it's probably very highly likely that this liquidity provider is the same person that created the exchange in the previous example. So now the liquidity provider can call a method, a function, which is on the new exchange that they just created. And in this case, in this example, we've created an Ethereum DAI exchange, right? And it's located at this address, the exchange address. So the liquidity provider interacts with this smart contract by calling the add liquidity function and passes in the number of tokens that they want to add to the pool, to the token pool. And they also send along some Ethereum using the value, right? So they pass along some Ethereum and they pass along some tokens to their liquidity pool. So let's say, for example, this liquidity provider provides 100 Ether and 25,000 DAI coins. So this is the end result after calling this method here. We end up with 100 Ether in the Ethereum pool, and we end up with 25,000 DAI in the DAI token pool. And so this now sets the price for Ether DAI. So basically, the liquidity pool's ratio between Ethereum and the token is determined by the amount of liquidity. And so with this example, we're essentially setting the price of 1 Ether to 250 DAI. And if the ratio does not match the current market rates, then this creates an arbitrage opportunity. And of course, arbitrage is how we actually, and how Uniswap keeps prices at certain levels with market rates. So as soon as an arbitrage opportunity is created, traders take advantage of that. And by taking advantage of these arbitrage opportunities, the prices start to shift in the right direction that eventually causes the exchanges to have a price that is near, or as near as possible, to the actual exchange. So once we have liquidity in our pool, we can start swapping tokens around, and that's what we're going to cover next. So the first example I want to go through is where a trader, our guy over here, or girl, is trading, and they want to swap some Ethereum for some other token. So this is called an ETH to token swap, and in fact what they do is they first find our shiny new exchange, which is our Uniswap exchange that the liquidity provider created earlier, and they call the ETH to token swap method here. And what this does is it adds Ethereum that's passed into this method into the Ethereum pool, and it will subtract or withdraw an equivalent amount of tokens based on the ratio or based on the price of the pair, so that you get your tokens back at the price of this exchange. So that's essentially what happens. Now, what are the actual functions? So again, what I've done here is I've broken down at a high level. I've taken what I see as being the four most important lines of code in the smart contract to actually achieve this. And this again is taken from the white paper. And so the first thing that happens is we calculate what's called an invariant. Now this is something that's related to the market maker formula, which is really what keeps the pricing in check. And this is something that I can discuss later in future videos. But for now, just take the fact that we need to calculate this variant at the very beginning so that we can calculate the amount of tokens we need to withdraw from the exchange. And it's simply the number of Ethereum in the pool multiplied by the amount of tokens in the pool. So that gives us the sort of current invariant, the current state of the exchange. Since we're adding Ethereum to this exchange, then all we need to do is simply add the amount sent in, which is in message.value, to the Ethereum pool. And that gives us our new Ethereum pool amount. And now we can use the invariant, and we divide the new Ethereum pool minus the fees to calculate what the total value of the token pool would be once we add the Ethereum to the pool. So it basically calculates the balance, the new balance of the token pool based on the Ethereum added, right? Which is obviously based on the invariant that we calculated. And that allows us then to calculate how many tokens that we need to send back to the caller of the function. And that is just simply the number of tokens in the pool subtracted by the new tokens in the pool, which is going to be less than the current pool amount. So that gives us the tokens out. So that's essentially the high-level view of how to do an Ethereum to token swap using Uniswap exchanges. Again, this logic here is coming from the white paper, and it's taken straight from the smart contract. So let's take a quick look at an example of this. How is this actually calculated? We'll use some real example numbers in this example here. So here we have an exchange on the left here, and actually these are both the same exchanges. It's just what we're showing here is the change of state from this state to this state as we make the exchange, right? As we perform the swap. So we have our trader, and the trader wants to swap 1 ether, so they pass in 1 ether via message.value, right? That could be through MetaMask or some other wallet that they use. And this 1 ether enters into the smart contract here, and it's passed into the ETH to token swap function. The current state of the exchange is that there are 10 ether in the ETH pool and 500 OMG coins in the token pool. And so the first thing we want to do is calculate the invariant. And the invariant is the number of ether times the number of tokens. So 10 times 500 is 5,000. And what we want to do is change the state of this exchange and essentially change the state of the trader's wallet so that the Ethereum increases and the tokens decrease in the exchange accordingly to the invariant, and the trader's wallet increases with the tokens that are sent out this exchange. And so how this happens with actual numbers, is as follows. So the buyer or the trader sends in 1 ETH, as we put here. So 1 ETH has been sent in. The fee is calculated like this. Now, it could be a different fee, but this is just an example. So 1 ether over 500 gives us a small fee for this transaction. Then we calculate the value of the Ethereum pool, which is the current value, 10, plus 1, which is what's sent in, minus the fee. So we're left with 10.9975. Then we calculate the amount that should be in the OMG pool based on the invariant and the new total of the Ethereum pool. So we divide the pool that we're adding to. We divide the invariant by the pool that we're adding to get the amount of tokens that are left in the pool we are withdrawing from. So in this case, we're adding to the Ethereum pool. So we take the invariant, 5,000, and we divide by the new total of the Ethereum pool, minus the fee, of course. And we end up with 454.65 OMG coins. So that is the total amount of OMG coins that should be left in the token pool once this transaction is complete. So then we can, from there, calculate the number of OMG coins that needs to be sent back to the trader, which is 500, the current value, the current token pool amount, minus the new token pool amount. And we're left with a number of tokens to send back to the trader, which is 45.35 OMG coins. And then we set the Ethereum pool to 11. So essentially the exchange state changes to this at the end of the transaction. We have 11 Ethereum, or 11 Ether in the Ethereum pool, or in the Ether pool, and we have 454.65 OMG coins in the token pool. And we have an invariant of 5,001.15. And note that since the invariant has shifted, the price of the Ethereum, the Ether OMG coin has dropped slightly. So if the trader makes exactly the same trade again, then we end up with fewer OMG coins. So this mechanism basically protects the market and protects the exchange and allows the exchanges to be autonomous. And this is one of the key success points of the Uniswap exchange. So this here is an example of how a trade works from basically an Ethereum to token swap. Okay, so here is another example. Here is a token to Ether swap. Here we have a trader. Again, in this case, this is exactly the opposite of the Ether to token swap. In this case, the Ethereum pool drops and the token pool increases. And the calculations are, again, exactly the same as the ETH to token swap, but of course in reverse, right? So we still calculate the invariant, which is the Ether pool times the token pool, and we calculate the tokens in, because we just simply add whatever the token was that's supplied, we add it to this pool. And then we just create or calculate the new ETH pool value, which is the invariant divided by the new token pool minus the fees. And that's how we get the Ether out. That's how we know how much to take out and return to the caller of the function. So this is pretty straightforward. Now, one last example. This is the Ether, this is token to token swap, right? And this is a very cool feature of the Uniswap exchanges, because Uniswap exchanges are paired with Ether pools. So each exchange has an Ether pool and a token pool. And in this case, we want to swap a token for another token. And so because each exchange shares the fact that they are all paired with Ethereum, with Ether, then we can now basically trade between tokens. And so what we have here are two separate exchanges. On the left, we have the Ether DAI, and on the right, we have Ether BAT. And we have this trader, and over here, we can see that the trader wants to basically trade their DAI tokens, so they're sending in DAI tokens, and they want to trade it for BAT tokens, behavior attention tokens, right? And so in order to do this, they need to call the token to token swap function on the exchange of the token that they own currently. So they call this on the ETH DAI exchange because they're passing DAI tokens in. And notice they pass in the address of the BAT token to perform this trade. So what happens on this side is actually pretty straightforward, and we've covered this already. You'll see that, first of all, we notice that the tokens pool is increased and the Ethereum pool is decreased. This is because we're adding tokens in, DAI tokens, and we want to get Ethereum out, because this can only swap DAI for Ethereum, but this trader wants BAT. So how do we get the BAT coin, right? So what happens is, in this side of the trade, the same logic as a token to ETH swap takes place, thereby adjusting the pool sizes as shown. And then we take the BAT token address that's passed in by the trader up here to find the exchange through the factory. Because remember, in the first example, we showed that when you register exchange, the factory registers the address of the exchange, and you can look up the exchange by the token address. So that's what's happening here. And then we can wrap that in an exchange class, essentially, and point to the exchange through an interface. And then we can execute the function ETH to token transfer, and we pass in the address of the trader. So that's message.sender. That's the address of this trader's wallet. And we pass in the value, which is the Ethereum that was deducted from this Ethereum pool. And then we head over to this second contract, which is the ETH-backed contract. And in this contract, as mentioned, we call the ETH to token transfer function. And this adds the Ethereum to the pool. So it adds the Ether that came out from this contract into this pool. And it removes the tokens accordingly based on the amount of the pool's current ratio. So in fact, what happens is the same logic as the ETH to token swap is performed, such that the tokens are removed and the Ethereum is increased, and then we just do a token transfer back to the trader's address for the amount of BAT tokens that are taken out. So if we look at that, essentially what happens is we end up with, if I just draw this in here, we end up with the tokens being sent back to our trader friend over here. So the tokens get transferred back to the trader. Okay? And so that is essentially how a token-to-token swap works using the Uniswap protocol. I'd like to finish up by just showing you a little bit of the white paper that I've been reading, and that's this one here. And basically, if you go through this, you'll see that it covers everything that I've been through in this video and more. So it covers things like creating exchanges. You just go down here, you can see the actual source code. You can see that it covers ETH to ERC20 token swaps, ERC20 tokens to ERC20 token trades, so token to token swaps. And you can see some of the examples here. You can see a description of what swaps versus transfers are, which is explained here. It's pretty straightforward. Adding liquidity. There's a bit on liquidity tokens, which I didn't cover, and the fee structure, which I didn't cover. So I highly recommend checking this out, because this is a pretty good description of everything that happens in the Uniswap protocol, and various code snippets from the smart contracts. So that's it. So take a look at the Uniswap protocol, take a look at the Uniswap exchanges, have a read of the smart contracts, take a look at some of my other screencasts where I go through actually integrating smart contracts with Uniswap using money Legos is what I did last time. And just have a play around and check it all out. And don't forget to like the video if you like this video, and subscribe to my channel, and I'll be posting a lot more content in the very near future. So thank you very much, everybody, and good day to you.